Hello, okay, my name is Dipo Areoye. I'm an Android developer based in California, and I'm here today to talk about fragments and hopefully reduce the fear of them. So, just to talk about expectations for this talk, it's mainly a beginner talk, but hopefully experienced developers in the crowd can still gain some usefulness from this and hopefully ask me some tricky questions at the end. I'm going to be telling the story of this of Fragments through this app called the World Cup Catch-Up. I don't know if you're a football fan, but myself, being in California, I found it hard to stay up to date with what's happening in Russia during the World Cup. So I wanted to create an app to, just keep up to date with what's going on and hopefully make sure Nigeria, who I was originally supported, is scoring some goals. So let's figure out what this app might look like. We have a very simple list pattern where we could see the list of games, and we click an item, and we launch some other type of screen which will give us, which will be the detail of that game. And I want you to think about a world without fragments, right? We'll probably go for, something like an activity. We have one activity on the left, one activity on the right, and it seems quite straightforward, right? So we have our main list activity, a match list activity, which will have something like a recycle view, our list of matches, some type of listeners to listen to updates, etc. And our activity on the right will have the detailed information for that game specifically. But then, of course, what if we had a tablet? We might want a different type of design. We might want the app to look a bit differently. We have the same concept, but now we want both screens to be visible at the same time. And we kind of run into one of the first limitations with our activity approach, where you can only have one activity on the screen at one given time. So what else could we do? We could probably think about maybe just having two separate views, managing the views in our sole, master activity. But then that would mean that we would have to, manage our own backstack navigation, and also our activity will start to become more and more complex, making it harder to maintain. And that's kind of the story, a little bit of the story of how Fragments came about. We wanted something that's more flexible and reusable. As you can see, we can use in both screen layouts, but still had some of the activity principles in allowing us to manage lifecycle of the device and also backstack navigation in build. So when I click on one item, I can press the back button, and automatically the manager, the activity can manage the transaction that takes place. So take a sip of this water. So the goal for today is just to reason about why I'm going to use fragments, and hopefully to keep that usage pain-free-ish by going through maybe some of the common pain points that developers or that I faced when I first started using them. So just a quick recap. We've talked about three-ish components. We have our activities, which are our top-level component. They're kind of like our entry level to our app. We have our views, which are very simple widgets. They're the actual elements you see on our screen, such as our list view, which we saw there. But they don't really have much knowledge of what's going on in the Android ecosystem. They're meant to be very simple. And now we're talking about fragments. So what are fragments? Or what is a fragment? The definition from Google told me that it's a small part that is broken or separated or something. And I like to think of this something as an activity. We have our activity that can do all these cool things, and we want to break some of that, take some of that functionality away, and allow us to, reuse this concept and create, highly customizable views that can still, manage a life cycle, receive its own input events, and can be added and removed using a fragment manager, which we're going to get to shortly. So a static fragment, so there's two ways to create a fragment. The first one is statically, and a lot of you will be familiar with this approach with XML. We can just define the fragment like it's a view and place it in our layout that the activity would then inflate. As you can see here, we have our horizontal layout. We have our list fragment on the left taken up. the left side and the detail taking up the right. We also have the dynamic fragment where you can create a fragment at runtime, usually in the activities on create method, just like a normal object, and then using the fragment manager, we can replace the fragment or add or create any transaction and then commit it in. What you might notice is that we're using this container list as the area in which we're pushing this fragment in. And this container, we still have to define in XML so that our activity knows, okay, how much space does this container take up, etc. So for our previous example, you can still have two containers, and this is for the tablet layout. We would have two containers, one container on the left, one container on the right, and the one on the right would be empty, or we can have a placeholder view, and the one on the left is where we can push the list. And when the user clicks the list, we can push another fragment into the detail. And also, we can send data to a fragment through fragment arguments, which is similar to how we pass data from activities to another activity. And obviously, communicating back to the fragment, to the activity from a fragment, will be done through an interface. So let's talk about the fragment lifecycle for a bit. The lifecycle, as you may know, is just essentially the steps that a fragment will go through when it's created or destroyed. Now, the one cool thing is that the fragment lifecycle was made to be very similar to the activity lifecycle. You might see some things you recognize. And this was done purposefully to help us, contain all our lifecycle logic inside a fragment without having to worry, oh wait, what's the activity doing? Because the activity should trigger the same lifecycle events in the fragment. But for me, when I first started off, this was quite overwhelming. I was like, I didn't know what I meant to, what parts of the lifecycle should I care about, right? And this also leads to a lot of issues when you actually look at, actually, let's go through the lifecycle steps that you should actually really care about to avoid confusion. So in the onCreate, our fragment is essentially initialized, and we should here initialize any components that we wish to be retained throughout the lifecycle, such as in our World Cup example, when we first launch our detail fragment, we want to make sure we grab the match information and retain it so that if the activity is paused or stopped and resumed, we still have that information, and the fragment can essentially reinitialize the views. And then in the onCreate view and view created, just like an activity, we can initialize the layout that we want to inflate, and then actually call methods to set text or initialize a list view, etc. And similarly, when the fragment is destroyed, we have to watch out for removing listeners or anything that needs to be persisted, because the user may not come back after this pause happens. So then let's look at what happens when we take a look at the fragment and the activity lifecycle combined. When we first start the app, we launch onCreate on the activity, and then that triggers our attach create and create view and activity create methods on our fragment. That makes sense. But then things get a bit weird because the following lifecycle methods are executed in parallel, which means that our activity on start can be called before or after the fragment on start. And even though the activity on start may be called before or after, that doesn't reflect when the on resumes will be called. So they can all be called in different orders from each other. And so that leads us to probably our first lesson, which is when we are overriding the lifecycle in a fragment, we should be mindful of the fact that just because our fragment is resumed, our activity may not be resumed, etc. So we shouldn't rely on logic that we placed in our activities lifecycle directly in especially in the onStart and the onResume methods in our fragment. So don't get overwhelmed and just be mindful of the activity lifecycle. So let's talk about how we actually navigate through fragments. So we had our very basic example where we went from a list to a detail. How does this happen? This happens with the fragment manager, which can be retrieved in any activity. So every activity has a fragment manager, or we can use the child fragment manager if we're dealing with fragments themselves, as fragments can have their own set of child fragments, similar to how a view can have subviews. You might notice we're using the support fragment manager here. As the fragment manager, the framework fragment manager has been deprecated to avoid inconsistencies with different Android platforms, which is a good thing. And so yeah, we use the fragment transaction, and we can then call all these different actions on our fragment, such as we can add a fragment, remove it, we can replace whatever is in the container, we can attach and detach, or we can show and hide. And what does navigation look like? So this is a quick step. We have our list fragment, and we have our fragment manager backstack. This backstack is created as soon as we call begin transaction, which you may have seen on the earlier slides. So we begin a transaction, and the activity, or the Android ecosystem, is going to create a backstack for you, which you don't really have to think about right now. And it's now ready for you to commit any transactions. So right now we have our detail fragment, and we want to replace that. We want to put that in place of the list fragment, so we're going to call a replace method. And now we can decide whether or not we want to add this transaction to the backstack. All this means is, do we want to keep record of this transaction, i.e., if the user presses the back button, do we want the transaction to be reversed? So we've added that to the backstack, and you notice that our backstack count has increased to 1 because we now have the replace the container with the detail fragment in our backstack. And when we commit these changes, the replace function will execute, which is actually just a combination of both a remove and an add. So we have removed the list fragment and added the detail fragment. So that's essentially what the backstack looks like, and that's a single entry. And once we commit, we have our detail fragment. You might want to notice though that the commit function is actually asynchronous and does not happen instantaneously, but for the sake of this example, we're just going to imagine it worked, everything worked fine. So we have our detail fragment. So what happens when the user pops the backstack and presses back? The first thing the fragment manager will do is look at the stack and see what's at the top of the stack. You will notice here that we have, like we said, removed the list fragment and we added a detail fragment. And it's going to reverse these functions. We're now going to remove the detail fragment and add the list fragment. And bang, done. Our backstack is back to 0, and we're back to where we started off. So let's look at a more simple example here, a more complicated example. We have our match detail fragment. This tells us what current game we're looking at. England is playing Croatia. We have a little square. We can have like a picture in there. But we have comments as well. Maybe users can add comments to the match. You know, I was frustrated with certain penalty calls, so I'd be like, hey, I want that ref valid or whatever. So you press the comment button, and you want to launch the comment fragment, which allows me to actually write the comments that I want. But hey, I'm not signed in, so we might want actually to put a sign-in fragment in place in between those two. So the idea is that if I press the comment button, my system can determine whether the user signed in, launch a sign-in fragment, then I sign in, and then I'm taken to the comment fragment. But of course, if you're putting user experience in mind, when the backstack is pressed, you want to skip directly back into the detail fragment as the user's already signed in. So let's imagine we follow the same procedure and added these 3 fragments onto our stack, with adding all the transactions into the backstack. We start with fragment A, we begin, we replace, we add to backstack, we commit, and now we have that remove A and add B onto our backstack. And similarly, we do the same with C. We remove B and add C onto our backstack. And now we've got our comment fragment, and we look at our backstack, we have both of these transactions in place. But we know that because of our special use case, we probably do not want to have one of these entries into our backstack, because when the user presses back with this current stack, we're going to see the sign-in fragment again. So my question to the audience is, which of these backstack entries do you feel we could have removed to allow us to go directly to fragment A when we pop fragment C from our backstack? If you think we could remove the second transaction, which was removing B and adding C, place your hands up. No, one person, thanks. And first one, do you feel that maybe if we remove the first transaction, A, and add in B, we will get the result that we expect? You guys are really good. Because this is the, where am I? So this is this initial mistake I made. I assumed that, hey, as long as I don't add my transaction when I place the sign-in fragment onto my backstack, when I press the back button, I would instantly go back to fragment A. And this is kind of what happens. So we started off with fragment B. We have the first entry on our backstack, and we removed A to replace B, of course. And when we add C, we do not add it to the backstack, and so now we have C. But of course, when we press the back button, the fragment manager looks at the stack and it's like, all right, you wanted to remove B and add A. B doesn't exist anymore, which is cool, so I'll add A. And I saw A and I was like, oh, that worked. But if you look actually at your fragment hierarchy, you never remove C and it still exists, which means that if the situation comes where A disappears, your user's going to see the common fragment for some weird reason. And that then takes us to our second lesson, to know that our backstack does not equal our fragments hierarchy. It's very easy to think that, oh, if I have fragments A, B, and C visible, then my backstack should reflect that, but you have to be wary of the transactions that you are executing, as the backstack only records the transactions that have taken place. So what is the solutions to deal with complex backstacks, and does the fragment manager help us with this? And the question is, not really. We have to actually implement some type of backstack change listeners to look at the backstack, and we can determine from the transaction entry count, oh wait, we can have to do some custom logic to determine on the backstack, from the backstack entries, which transactions that we want to remove. Or we can override the unback pressed from the activity cycle and actually just commit the transactions ourselves. You could also avoid backstack notification for the specific example of child fragments, where, for instance, we go from fragment A to B, B to C. But instead of launching C from the activity, we launch C from the fragment B. So now C is a child of C. And then when the user presses the back button, we only have one transaction, which is remove B and add A, and we get back to where we want to. So I feel like for backstack management, when you're doing anything complicated, the fragment manager will require you to definitely get your hands dirty and go into the backstack. There are not really any easy solutions for that. But the good thing is that the fragment manager does follow a logical procedure, and we can add tags to certain entries, so we can keep track of transactions which we might want to handle ourselves. The second problem I ran into was with running asynchronous tasks in my fragment. I'm going to present to you a use case where a user is once again on the detail fragment and is refreshing to get an update on the scores, but probably in a low connectivity situation, so the refresh is taking a while, and the user carries out an action, one of these four, which stops our activity and blocks our fragment from running. But in that aspect, while the user pressed back, for instance, I went to the home screen, our asynchronous task has completed, and it's like, hey, I've got this match update for your fragment, and we try to update the UI. Now the issue here is that, as you could imagine, the fragment is actually no longer attached to the activity. So we run into a common problem known as the illegal state exception. Also, you can run into this problem as well if you're trying to commit fragment transactions whilst the activity has already saved the state. And by that I mean the activity has been stopped. And as we know, when an activity stops, it tries to save the state. And if you're trying to commit a transaction in this scenario, you once again run into the illegal state exception. So once again, how do we stop this from happening? Are there any solutions? Firstly, you have to be mindful that making fragment transactions and UI updates from asynchronous callbacks is something that we have to handle with extreme care, and if we can, we should generally try to avoid it. But we do have solutions. So the first thing we can do is we can check to see if the fragment is added to the activity before updating the UI. This can be done for a simple is added check on the fragment, or if, for instance, we could also look at the fragment lifecycle, and when the fragment is paused, we can add a flag so the fragment is aware that, hey, I'm not currently available right now, so that when the callback comes in, we're aware of that. And finally, probably the most appropriate thing to do is to take out these asynchronous tasks from the fragment, like completely. And there's a special class for this which came around, I think, last year, known as the view model. So this is taken from Google's documentation diagram, and essentially it tries to explain what the view model's goal is. We have our UI controller, which in this case is our fragment, and we can get a view model, which in this case would be like our match detail view model. And our view model's whole sole responsibility is to get the data that we want. And this is a synchronous task, so it has to deal with all of that. It has to fetch it from the cloud, deal with an API, and then store this data for us. But most importantly, it has to retain this data whilst the fragment or the activity is destroyed and recreated. And then obviously we can observe on this view model when this data has been updated, and we can essentially just update our UI from there. And this is cool because we've separated our getting the data logic from updating the UI logic in our fragment. So our fragment's only caring about, is there data for us to update? Also, if you're wondering how this stops the illegal state exceptions, because now when as the fragment's aware of the activity lifecycle, when it's destroyed, it can essentially remove any observers on the view model and resume them once, and re-register once it's received. Also, there's also those situations when maybe I'm listening for an event, such as when a goal is scored and I want to push information directly to my fragment. And once again, in that case, that we've solved that situation because our fragment, if it's not available, won't even be listening for the event in the first place. So that's the view model. So the summary there is we shouldn't be overwhelmed with the fragment lifecycle. We shouldn't also be afraid to customize the backstack. We have loads of helping methods for that. And we should try to take asynchronous tasks outside of these fragments. So what else are fragments good for? When my first ever Android app I created, I remember I was using a view pager, and I was fascinated by this cool UI that I used to see on loads of social network apps, such as, I think it was Snapchat at the time, or Twitter, that allowed us to transition from whole elements of the screen with one single swipe. And it was amazing that the Android SDK provided us with this view pager element that allowed us to get this really for free. And this element was designed with fragments in mind. It follows an adapter pattern, which means that we can just tell it what fragments we want to use, and it essentially handles the layout for us. We can also use special layouts and special adapters for fragments that allows us to manage the memory fragments of screen so that we can destroy fragments of screen and then restart them when we swipe in, which is something that if we try to implement ourselves, would be really tricky. And if you look back at our example where we had our site, where we had our World Cup fragments, such as the list or the activity, or the detail fragment, it's really cool because you can just put your fragments in there and they just appear as you expect them to be without any more customization. There's also this really cool thing called a DialogFragment, and as you know, dialogues are used in almost every app. The main thing I came across with DialogFragments is that they allowed me to customize the look of my dialogue with something I was already familiar with, which was a fragment. But they actually provide more use than that. They allow us to once again, because they are fragments, actually have whole navigation flows inside our dialogue. So for instance, going back to our sign-in problem, where we had our sign-in fragment, we could present that to a user on a dialogue if they're on a smaller device. And that means that I can handle all the logic for my sign-in flow inside the dialogue. And once I'm done, I can return back to my standard fragment, and that will all look like a normal fragment transaction. It also means it keeps things flexible because it's still a fragment. I can use a dialog fragment as a normal fragment, for instance, for my tablets, and just display them as normal. Also, being fragments, they have a lifecycle, and we can save and restore the states of these upon device rotation or exiting and reopening the app. And then there was this thing which I came across a couple years ago when I was dealing with, I believe it was the Braintree API called a HeadlessFragment. And I noticed that when I was interacting with the Braintree API, you were interacting with a Braintree fragment, but it was never visible. And the idea of a headless fragment is that it's not actually an official class. It's essentially your normal fragment with set retain instance set to true. And this just allows us to retain the fragment no matter what's going on in the activity lifecycle. So you should think of this more of a encapsulation of your data and a way to preserve data across the activity lifecycle. And it's funny because that's exactly the same objective that our view model has. But it's cool to know that Fragments actually had a use case for view models before view models were even came into conception. And it's all that simple call, set retain instance to true. You should be careful though when using a headless fragment that because they're going to be continuously retained, that they don't have any references to your activity, as that can lead to the activity not being destroyed and thus memory leaks. So, one of my most recent projects, I had this existing application, and it was mainly built based on a fragment architecture. We had a view page, or we were using custom dialogues. But we wanted to have a hybrid web app to handle our payment transaction flows, because these flows we were changing on the fly. We didn't want to have to release a map update every single time we made changes to the payment flow. So we decided to use a web app which we could activate through the Android web view. And we needed this to, of course, persist throughout our whole application. This is because at any given time, the user might be required to launch a web view, and we wanted to show instantly and not have to reinitialize and rerun the JavaScript code. We just wanted to appear so the user cannot actually tell that we're using a web app. But I noticed that the problem with the web view was that even when we retained it, every time I would replace the fragment and bring it back into view, the web view would always reinitialize. And that's because even with a retained fragment, even though the fragment is retained, the view is still destroyed, and the web view has to reinitialize itself every single time I was showing it. So we had to take a closer look into the fragment transaction, And we realized that, all right, we put the web view in as its own fragment, and we could customize the replace call in our activity. So what we did in our activities, instead of removing the web view, we would always just hide it. And that meant that the activity, the web view fragment would always run. Our web app is always persistent and it's always in the same state, but the user cannot see it. And now we can show and hide at will. And this was actually a really simple solution, and without fragments, it probably wouldn't have been straightforward. So, it looks like I've gone way ahead of time here. I've reached the end already. That's it really, that's Fragments for me. I would say that they're a good step for, the first step for Fragments would be, if you're trying to break down huge activities, you could start off with a fragment. Try to figure out what portions of your UI you can separate. So going back into our initial flow, it's very easy to see that we can handle a list and a detail separately. But you might be able to even break things down into smaller pieces. Maybe you have like toolbars that you're using, or even certain types of footer views. If you want reusable UI components and lifecycle out of the box, a fragment is a good start. And you should just think of it as a functional unit to display a portion of the UI with a specific purpose. And usually a fragment will have to be dealing with one or more views in this hierarchy. And like I said, for ease, just keep the background tasks out the fragment, use a view model, or if anything, try to use your activities to deal with your asynchronous tasks. And try to keep your fragment concerned with just updating the UI and containing the UI and allowing other developers to work with your app. So that's really Fragments, that's me. You can find me on Twitter, Dipo Areoye. I hope this talk was useful. Any questions, really? Thank you very much.